should be looking at your beautiful unit circle that we created yesterday. And we talked about a lot of stuff. Remember, I told you you absolutely have to know without looking at anything. Today is just the radian values for the first quadrant, because there's a whole lot more eventually we're going to have to know, but we're going to baby step our way through it. And I want to make sure that you understand how to use this, because as I went through the day yesterday, I kind of thought some people did, but some people still didn't. I want you to remember that your values are always cosine theta, sine theta. That's what these ordered pairs give us. So when you look at your unit circle, if I ask you, what is the cosine of 2 pi thirds? You should be able to at least use the unit circle right now, even if you can't just tell me off the top of your head. 2 pi thirds, right? And is cosine x or y? X. So I look at my x value, and the cosine of 2 pi thirds is -1/2. Make sense? What's the sine of 2 pi thirds? Square root of 3 over 2. Okay? What is the cosine of 7 pi fourths? Square root of 2 over 2. What is the sine of 7 pi sixths? -1/2. Okay, so do you see how to get the numbers off of the unit circle? Okay, because that's something we got to make sure that we get right now before we move on to any of the rest of it. Okay, are we good with all that? Okay, so I want you to keep this handy, but close it, because I don't want you looking at it right now. I want you to take the piece of paper I gave you, which looks like this, and without looking at anything or anybody else's paper, you're going to kind of quiz yourself. I'm not taking them up. They're not a grade. We're just going to see what you can really do here. I want you to write down, just write on the inside of the circle, like right here, what the radian values of these angles are. Okay, so I'll give you the first one. This is 0. Okay, so you have 4 more radian. I know, you're welcome. You've got 4 more radian values. Do the best you can. Put in there what you think it is. Don't wait for me to do it. I'm going to see what we can dig out of your brain. All right. Wait. Okay. Wait. As long as there's no cheating, I'll wait. All right. So we should have 0. We know that 90 is pi halves, right? 45 halfway is pi fourths. And then we only have 2 numbers left. Like, there's only so many to choose from, so it's not like you have to worry about pi sevenths or pi ninths or whatever. This is pi sixths, and this is pi thirds. Right? We good? Awesome. If you're not right, fix it, because I don't want it to be wrong. Okay? And we'll just practice writing them down multiple times. But that's what your order is. Notice the denominators get smaller as you go around the circle there. Okay? Now, your values for your ordered pairs, okay, not something I expected you to just know today. We're going to talk our way through it a little bit. We should be able to figure out these two, though, pretty easily, right? For 0, what is this ordered pair? 1, 0. And for pi halves, it is 0, 1. Okay? Those are the easiest ones, really. Then for the rest of them, you only have 3 values you have to know. We just got to put them in the right spot. Your values are 1/2, square root of 3 over 2, and square root of 2 over 2. So to make sure that you keep these 2 straight as to which angles they go with, the one that has the x and y value that are the same, 2 values that are the same, has the square root of 2 in it. So which one of these 3 has the x and y value that are the same? Pi fourths, right? Because it's a 45, 45, 90. Yeah, that's fine. So this is square root of 2 over 2 and square root of 2 over 2. So the one with a double value has the square root of 2 in it. Then I just have to make sure I get 1/2 and square root of 3 over 2. They go in both of these. I got to get them in the right order. So think about plotting points. It helps to be able to picture this in your mind. I watch y'all when you're taking quizzes, or even if I'm quizzing you at the door, sometimes people's eyes kind of go around in a circle, or even their finger, because they're kind of thinking in their head, which is great. You want to be able to picture this. First of all, the 1/2 and the square root of 3 over 2, which one of those two is a smaller value? 1/2, okay? So when you think about plotting points, if you can picture where pi6 is in the circle, and you think I'm going to start from here, I have to go to the right, and then I go up, which one's smaller, my right or my up? My up, right? Which means my y value is smaller, so this has to be 1/2, and this has to be the square root of 3 over 2. When I think about plotting the point for pi3, if you picture where that is, then I'm here, I go to the right, and then I go up. Well, I go to the right less than I go up, so this has to be 1/2, and this has to be square root of 3 over 2. Okay? I'm going to give you an even better way to remember those, but everybody's brain works differently. So if you're thinking visually, that should help you get those all filled in. All right? Are we good with that? Questions about that? Okay, so I want you to fold this in half with this on the outside, because you're going to look at the one below it, but I don't want you to be able to see this one. I'm going to train our brain. So just fold it in half like this with these on the outside. That way, when you look at the bottom one that's blank, you can't see the top one. That's my goal here. And it's the first quadrant, so once you fold it and then you're trying to figure out like which way to turn it, make sure it's turned like this. That puts the crease at the top. So you want to look at the blank one, crease at the top. I know everybody's flipping around. We all good? Does it all look like this when you're looking at a blank one? Okay. So the first thing I want you to do is I want you to fill in the radian measures again. Then when you're done, double check yours with mine. Make sure we agree, but don't just copy mine down. And if we don't agree, fix it because mine are right. Okay? All right, so then I want you to just do the best you can to fill in the ordered pairs without looking at anything or looking at anybody else's paper. If it's wrong, it's okay. We can fix it. I just want to see what you can dig out of your brain right now. Give you enough time? All right. So this one we know is 1, 0. This is 0, 1. Please, Lord, don't ever get those mixed up, right? Then pi4, we know they're the same, so it's square root of 2 over 2, square root of 2 over 2. Pi6 should be square root of 3 over 2, 1/2. And this one would be 1/2 square root of 3 over 2. How do we do on that? Not so bad, right? It's really not as bad, and I'm even going to give you an easier way to remember those things. So, because it's one thing to fill in the whole circle because you can look at the patterns. It's another thing if I just ask you about one angle. You got to be able to keep that straight also. We're going to get there, okay? But let's talk tangent first. We know that, first of all of these ordered pairs are cosine theta, sine theta, right? And we know that tangent theta, was it sine over cosine or cosine over sine? Do you remember? It's sine over cosine. I know we did that right at the end after I'd already filled your brain with a lot of stuff yesterday. But tangent is sine over cosine, so that is something that we got to make sure that we know. So we're going to come up with our tangent values. Sine over cosine, which means y over x for all of these. So if I start with pi halves and I do y over x, that's 1 over 0. Think before you speak. What does that give me? No. Nothing. Undefined. You cannot divide by, look at my posters over there. N over O, undefined. You cannot divide by 0. Okay, O is on top, you're fine. Okay, so this is undefined. If I go to 0 and I do tangent, that's y over x. I put 0 over 1. What's that? 0. Okay. All right, so then if I do square root of 2 over the square root of 2 over 2, what does that become? 1. They're the exact same thing, right? So they just cancel out and we get 1. So the tangent of pi fourths is super easy. Pi thirds, we did it yesterday, but I know you don't remember it, and that's okay. We're going to do y over x. So I have square root of 3 over 2 over 1/2. So that becomes square root of 3 over 2 times 2 over 1, which ends up just giving me square root of 3. Yes? Okay, so then for pi sixths, that would be 1/2 over the square root of 3 over 2. So when I keep change flip, I get 1/2 times 2 over the square root of 3, which gives me 1 over the square root of 3. And when I rationalize, what's that? Very good, square root of 3 over 3. So if you look at these values for tangent, the 0 and the undefined, even if you don't remember which is which, should be easy to calculate each time if you actually know if you can divide by 0 or not. Pi fourths is pretty easy. It's 1. They're the same, so they're going to divide out. So you really only have 2 things that you have to remember, and they both have a square root of 3 on them. And the easy way to remember that is the one that has 2 3s in it goes with the 6. The one with 1 3 goes with the 3. Okay? 2 3s make a 6, 1 3 makes a 3. Okay? We good? So once all is said and done, it's not going to be that bad to kind of keep up with them. All right? We good at this point? Awesome. Okay, so we're going to pause on that paper. We're going to come back to it at the end. So now you each need, I'm going to come around and give you a hand, and y'all can just fight over the colors. Yeah, we'll see. Survival of the fittest here, I guess, when you fight over them. How important is what color it is to you? I think that's 4. I'll come back around if it's not enough. Oh, here, y'all don't even have to fight. Here, I'm not even going to let y'all fight. Okay. Everybody have a hand? Joel, give the hands out. Pass the hands out. You don't get them all. All right. And you also need one of these. And there's 2 glue sticks in the box that your phones were in. So if you will get those out, you may have to share with at most 1 person. Sharing is caring, so let's be nice about it. No, it was the best I could do. Trust me, I have these cutouts are a different size than I've used before because I was buying them and somebody was nice and cut them out for me, and then it didn't fit on the hand I had on the paper before, so I spent forever trying to find a hand where this would fit, and I tried editing them, but I'm not good enough to do that, so yeah, it was, yeah. This is the best I could do, all right? Okay, so you've got this. Well, first of all, let's just look at the piece of paper. You have an x-axis right here and a y-axis right here, and then there's a line next to the y-axis. That was a gift from the copy machine, so just ignore it. I'm not real happy that it's that close to the y-axis, but we're going to use this. Now, I could teach you this just using your own hand, which is really what you're going to do, but I think it's better for everybody to wrap their mind around it when you actually have like a different one that you're using it on. But if you hold up your left hand, your palm facing you, you should be able to make your pinky finger the x-axis and your thumb the y-axis. Does that make sense to you? It's basically what we're doing, and we're just going to use this hand to kind of help us. All right, so that you put the glue in the right spot. Let's take this hand, and you're going to place it down right on top of the hand that's there. Do not put the glue on this side because that makes no sense, okay? You're now going to flip it over, put glue just in the palm of the hand, and then flip it back over to glue it down, all right? So you set it down so you know that it's right. Then you flip it over, put glue in just in the palm, and flip it back over. Don't glue the entire hand down, just the palm, so that it covers it up, and let your glue stick. Oh, here, y'all only had one. I'm sorry. It's because I stole it last period. Oh, good Lord. That's what you get for not handing the hands out. Yikes. Okay. So you just glued right on top of some words. So we're going to have to rewrite them right here, which is going to be hard. If you put glue there, you might have to wait for it to dry. This was a big old square root, and inside it said number of fingers over 2. Which might sound strange, but that's okay. All right, so if your pinky is on the x-axis and your thumb is on the y-axis, then angle measure-wise, this is at 0 radians. Your thumb is at pi halves. All right? That means your middle finger is at pi fourths. Then your index finger, what radian measures this? Pi thirds. Very good. And this one is pi sixths. Okay. So everybody hold your left hand up, palm facing you. All right. Now bend back pi fourths. Okay. Do it. All right. Now put that back. Where's pi sixths? Right here, right? Your ring finger. All right, put it back. Where's pi fourths? All right, put it back. Where's pi thirds? All right, make sense so far? Okay, let's see why we care about that. So when you bend this back, what this whole square root of 2, I'm sorry, it's not square root of 2, square root of the number of fingers over 2. We know that our ordered pairs are always cosine theta, sine theta, right? So let's write that down again. Cosine's on the left, sine's on the right. So we're going to take pi thirds, your index finger, and you're literally going to fold it back. Okay? Just like you would do like on your own hand, right? Okay, so when you look to the left of that finger, you have one finger. We're not going to debate whether or not a thumb is a finger. It is right now, okay? So you got one finger. The square root of the number of fingers over 2. What's the square root of 1? 1. Not a trick question. It's 1. Square root of 1 is 1 over 2, so that's 1/2, right? So your x value for your ordered pair is 1/2. It's really not, I promise. The 3 over here, I've got 3 fingers to the right. That's the square root of 3 over 2. So when you take your index finger and you bend it back, you've got your cosine value and your sine value for pi thirds. It's 1/2 and square root of 3 over 2. That's your ordered pair right there. Make sense? So when you're taking a quiz, and even at the door, I expect it to kind of look like you're playing air guitar, all right? I use the hand trick too, just because these numbers, they're easy, but to make sure I got them in the right place so I don't think wrong quickly, all right? So let's put that one back. Now let's take pi fourths. Let's bend that back. So I'm going to have an ordered pair. I've got 2 fingers to the left, so that means that's the square root of 2 over 2. I've got 2 fingers to the right. That's square root of 2 over 2. Make sense? All right, so we're going to put that finger back, and we'll bend back pi sixths. To the left, I have 3 fingers, so that is square root of 3 over 2. To the right, I have 1 finger, so that's 1. Oh, not it's 1. Oh my God, it's 1/2. Jeez. It's 1 over 2 is what I meant to say. 1 over 2. Easy enough? Now, it works for your thumb and your pinky finger too. Not that I think you necessarily need it. It actually makes it, to me, it does make it more complicated on those, but let's see how that works. Let's bend this one back. okay? So to the left of this, I have 4 fingers. What's the square root of 4? 2 divided by 2 is 1, so my x value is 1. And I have no fingers to the right, so it's 0. So it does work. It's just, maybe it's easy, but maybe that's better for you to keep up with which is which. Let's bring back pi halves. To the left, I have 0 fingers. To the right, I have 4. Square root of 4 is 2 over 2 is 1. Okay. So if I ask you, what is the cosine of pi thirds? Pull this finger back. You got 3 fingers over here. Your I'm sorry, I said cosine, didn't I? My cosine is 1/2. All right. So let's use your real hand. You have to use the left hand or you're not in the first quadrant. Okay, palm facing you. And so don't look at the paper. Just say, all right, pi sixths. What is the cosine of pi sixths? This is pi sixths. So my cosine is square root of 3 over 2. Make sense? Okay, and then if it's pi fourths, if you don't remember they're the same, as soon as you do that, you should be like, oh yeah, they're both square root of 2 over 2. Okay, so just whatever, but the hand trick, super helpful. And I always have some kids at the end go, yeah, I never really did get the hand trick. Probably because they didn't pay attention the first day and then they never figured it out. If you don't understand what I'm saying, please let me know and I will re-explain it to you 1,000 times because this is going to be a lifesaver for you. Okay, are we good with that? Awesome. All right, so let's talk about tangent values. So this hand trick is kind of a universal thing. SOHCAHTOA is kind of a universal thing. The tangent value trick, which is not really necessarily a trick, actually came from, I had a student say this to me a couple of years ago, and I was like, I have never heard this before. And she was like, I don't know, my teacher taught me that. Like, she had come from a different district, and they had already done the unit circle. And I was like, okay. So I emailed her teacher, and I was like, hey, I've never heard this before, but I'm stealing it. I just want to let you know, thanks or whatever. And he was like, yeah, I made that up myself in college because I couldn't remember them, so I had to come up with something. So this is just something some random guy that now teaches somewhere else came up with, and then I stole it from him, but I told him. All right, so let's talk about our tangent values here. We have this little saying, which is not really, it's kind of an acronym, but not really. You are one really overwhelming third wheel, which sounds insane, I know, but here's how this works. The U is for undefined. The word R or something that starts with an R is a square root because the square root kind of looks like an R, right? So it's a square root of 3 for the R and the really. 1 is 1. Overwhelming makes it a fraction. It's over. Third is just 3. Wheel is 0. Okay, so I know it's kind of strange or whatever, but trust me, it works if you need it. If not, there's other ways to know it. I'm just throwing it out there. So the first thing I want you to do is go ahead and fill in your radian values like you had done before, because you can do that on your own, I know. Okay, so let's double check again that we agree with all those, right? Okay, so as we go around the circle, you are one really overwhelming third wheel. So U starts right here. That makes this undefined. R comes next, so that's the square root of 3. 1. Really, that's another R. And then overwhelming third, really overwhelming third wheel. There are your values right there. Which helps if you're trying to get in the whole circle or whatever. But remember too, these you can come up with easily. This being 1 should be easy to remember. 1 3 goes with pi thirds, 2 3s goes with pi sixths. Okay. We good so far? Awesome. All right, so what I expected you to know today, 100% on your own without looking at anything, are these angle values in radians, and I think we pretty much got those down. By Monday, I want you to know the sine and cosine for the first quadrant, so you can use your hand trick. Hopefully, you probably already got those down, okay? You could be working on the tangent values, but we're going to take this a step at a time so it's not too much all at once, because we're going to talk about some other things today so you can see some patterns. But remember, I don't want you to think about this as, oh my God, I got to know all this to be able to write it all down right now. Okay, we're just going to practice some. We good? All right, so grab your other piece of paper again. Let's go back to that. And so on the other side, you have a full unit circle. The little lines that are here are the fraction bars, which I could have left off, I guess, but they're there. So the first, what I want you to do right now in here with those fraction bars already there is just in the first quadrant, I want you to write in your radian values once again. You should be an expert at that by now. Just the first quadrant and just stop, yeah. Are we experts at that by now? We got that down, right? Okay, so I want you to finish this up with me. Like, don't go in and fill it in if you feel like you already know it, because we're going to look at some patterns here. We know that 180 is pi. When we think fractionally, right, I'm here at 0. This is pi halves, which makes this 2 pi halves, which makes this what? 3 pi halves. So this is 3 pi halves. All right, so now we're going to go fill in all the pi sixths angles. Okay, so my pi sixths angles, I know all of them are the ones that are closest to the x-axis. So this is going to be over 6, over 6, over 6. And we're going to come up with them thinking fractionally. If this is 0 and this is pi, that means that this is 6 pi sixths. Does everybody understand what I mean when I say that? Because 6 pi sixths is 1, right? So if this is 6 pi sixths, I'm going to back up 1. That puts me at 5 pi sixths. I'm back at 6 pi sixths. I'm going to go forward 1. That puts me at 7 pi sixths. Right? If I go all the way to 2 pi, how many pi sixths is that? 12. This is 12 pi sixths. So you back up 1 and you're at 11 pi sixths. We all good on the pi sixths? You see how to think. If you think from the x-axis and just go up or down, it's going to be the easiest way for you to figure out what's in what quadrant. And then once we're done with all these, I'll show you some other patterns. All right, so let's look at the pi fourths. Those are all the ones that are in the middle. So this is over 4, over 4, over 4. Okay? So if I'm thinking in terms of fourths, what I'm here, this is 4 pi fourths. I back up 1, that puts me at 3 pi fourths. I go back to 4 pi fourths, and I go forward 1, that gives me 5 pi fourths. When I go all the way to 2 pi, how many pi fourths is that? 8. So I back up 1, and that gives me 7 pi fourths. All right. Then let's look at pi thirds. So those are the remaining ones. They're the ones that are closest to the y-axis. This would be 3 pi thirds. I back up 1, that's 2 pi thirds. 3 pi thirds, go forward 1, that's 4 pi thirds. All the way to 2 pi is how many pi thirds? 6. I back up 1, that puts me at 5 pi thirds. Okay? Think from the x-axis and things will be helpful. So because we went to the x-axis and then backed up 1 to get in the second quadrant, in the second quadrant, all of the numerators are 1 less than the denominator. And in the third quadrant, all the numerators are 1 more than the denominator, because we literally went to where they were equal and went back 1 or forward 1. You with me on that? So that's going to help you when you get 7 pi sixths, and then you have to know what quadrant it's in. You can think, oh, 6 pi 6 plus 1, that's in the third quadrant, or the denominator is greater than 1. Like, it'll be easy. It'll get easier. It may not seem that easy right now, but I promise, the more you see it, the quicker that's going to get for you. And then this isn't like 1 or less or more, but it's 5, 7, 11. But again, I would just go to 12 pi and back up 1 or whatever. Okay, we good on that? What questions you got? Oh, the 0 is 2 pi. Yes, thank you. I probably should have put that from the beginning, and I didn't. We good? Awesome. All right, so your paper is folded in half. You may have to fold it back. So basically, I want you to be able to see the next circle without seeing this one. And then I want you to do the best you can from what we just talked about. I know it's fresh in your mind. Fill in all the radian angles without cheating on anything. Just see what you can dig out of your own brain. Okay, have I given you enough time? Go ahead and fill these in then so you can check yourself. So looks like most of you did pretty good. If you're done, I'll give you some more time. You don't have to, don't want you to look up here and just copy them down, but double check yourself with me. And if you couldn't get them all, but you got some or most of them, that's good, okay? Because we literally just did it, all right? So we just got to practice some more and more. The more you write them down, the easier it's going to be for you as we go, okay? How are we doing? We good? All right. So now what I want you to do is I want you to, in the first quadrant, fill in all of the ordered pairs. Without looking at your hand, flip all that stuff over. Just do the best you can. See what you can dig out of your brain at this point. You can use the hand trick, just don't look at the paper. Like, use your own hand and figure it out. Once you're done, check yourself up here. See if we agree. All right. Okay, so let's talk about the rest of the circle with these. Because if you can get the first quadrant down, the rest is cake. Because the rest is just using your reference angles and knowing about your quadrants. So we've known for a long, long time that in the first quadrant, all of your points are positive, positive. In the second quadrant, your x is negative, your y is positive. In the third quadrant, they're both negative. In the fourth quadrant, it's positive negative, right? So if I asked you about 5 pi sixths, right? For your hand trick, there's no 5 pi sixths, and there doesn't need to be. You use pi sixths. This is your cosine, this is your sine. But then you have to know that 5 pi sixths is in the second quadrant, which makes your x value negative, right? So remember all that reflection stuff we did? If I know what my values are for pi sixths, then that's the same for 5 pi sixths. I just have to make x negative. So this would be negative square root of 3 over 2, positive 1/2. Which means same for 3 pi fourths. They're both square root of 2 over 2, but this would be negative square root of 2 over 2, square root of 2 over 2. And then 2 pi thirds, my reference angle is pi thirds, so this would be negative 1/2 square root of 3 over 2. Pi, what would that ordered pair be? Negative 1, 0, right? Because you know where it is on the axis. So third quadrant, it's negative, negative. Pi 6 values are still the same. It's the same thing from my hand trick. I just got to make them both negative. So it's negative square root of 3 over 2, negative 1/2. 5 pi fourths would be negative square root of 2 over 2, negative square root of 2 over 2. 4 pi thirds would be negative 1/2, negative square root of 3 over 2. What would 3 pi halves be? 0, negative 1. All right. You think you can fill in the fourth quadrant? I think you can. Go ahead and fill in the fourth quadrant. If you know the first quadrant, you know the entire circle. We've just got to get used to knowing which quadrant we're in, which is going to come, I promise. We're going to get there, baby steps, but I want you to see it at least, okay? We good at this point? All right, go back to the other circle you have that just has the angles on it. And we're going to talk about tangent on here. So we can put our tangent values on here a couple of different ways. Let's go ahead and use our little saying. U, which makes this undefined, R, square root of 3, 1, really overwhelming third wheel. Right? There are your tangent values. All right, and then we know that our quadrants, this is positive, positive, negative, positive, negative, negative, positive, negative, right? That's for your x and y values. Tangent isn't x and y, it is actually y over x, right? So we're going to make a fraction out of it. If I put my positive y over the negative x, my answer has to be what? Positive or negative? Negative. So that means in the second quadrant, all my tangent values are negative. And my reference angles work again, because if this pi thirds is the square root of 3, that's the number that goes with 2 pi thirds, because that's my reference angle, but I'm in the second quadrant, so it's negative square root of 3. 3 pi fourths would still be 1, but I'm in the second quadrant, so it's negative 1. 5 pi 6 would be negative square root of 3 over 3. For pi, my ordered pair is negative 1, 0. So what is my tangent value? If I put y over x, that gives me 0. So it's the same as the axis is the same. In the third quadrant, to create tangent, we'd put negative over negative. What does that become? Positive. So your tangent values in the third quadrant are all positive. Go ahead and fill them in. What do you think 3 pi halves is going to be? Undefined again. Good. And then in the fourth quadrant, would tangent be positive or negative? Negative. So go ahead and fill those in. So even with tangent, once you know the first quadrant, you know the rest. Right? And then from there, we could also get our reciprocals, but we're going to wait on that because we got to make sure we get all these down first. Okay. So I expect you on Monday to still remember the radian values. We can't forget what we already knew. Your sine and cosine values for the first quadrant, and then maybe the tangent values. Be working on those. Okay. We all good on that? Any questions? When you are doing your assignments in Delta Math, please try to do it without looking at any of this as much as you can. If you need to, like, at least even if you're afraid to get the answer wrong, like, do it and then double check yourself, but try and start getting it out of your brain. Maybe having a little piece of scratch paper where you can jot down things in the first quadrant so you can see it. The more you write it down and look at it, the more you're going to know it. Okay? Are we good? Awesome.